Hey guys, in today's video, we'll be covering Unit 2.10 of the Math AA, SL, and HL course, which is solving equations. So first we'll start with analytical methods, and these are where you don't use a calculator, but use like laws, formulas, and analysis to solve a question. And you already learned some analysis methods, such as computing the square, quadratic formula, and all that. But today we'll be learning substitution. Substitution. And this is useful for solving quadratic questions in disguise. And what do I mean by quadratic questions in disguise? Let's have this question here, right? We have 25x minus 4 times 5 to the power of x minus 5 equals 0. And how is this a quadratic, you may wonder? Well, first things first, we can rewrite this 25, right? This 25 here is 5 squared, right? And next thing, we know that using index laws, exponent laws, that 5 squared to the power of x can be rewritten as 5 to the power of x squared, right? You just switch these two around and it's the same thing. And you just keep going, times 5 to the power of x, 5 equals 0. And now you have your quadratic here. You have something squared minus 4 times your variable minus 5 equals 0. And this is where you can use substitution. You let 5 to the power of x equals a. You substitute in a, except instead of 5 to the power of x. So now you have a squared minus 4a minus 5 equals 0, right? You just put the a here and here instead of 5 to the power of x, and you have a quadratic. And you can use the quadratic formula to solve this, or you can just factorize. If you don't know how to do this, you can watch 2.8 and 2.9. They explain how you use the factorization method. But you just factorize, and now you have a equals 5 and a equals minus 1, right? But this isn't the answer to the question because we're looking for x, we're not looking for a. So how do we find x now? Well, if we go back to the substitution, we know that 5 to the power of x equals a, right? So 5 to the power of x equals, and we know that a is 5, so equals 5. Or we also know that a is also minus 1, so it can also be minus 1, right? And now we solve for x. So we can rewrite this as a logarithm equal x. And log base 5 of 5 is just 1, so 1 equals x. So 5 to the power of 1 is 5, that's correct. So we know that x equals 1. Or we can, here again, rewrite as a logarithm. And we know that for logarithms, this number here has to be greater than 0. And since it's negative, this means that there is no solution, right? So here we have your answer is x equals 1. And now we move on to graphical methods, which is where you use a calculator or another graphing tool to solve questions, solve equations. So let's say you had two functions, right? You have f of x, which is equal to 5x cubed minus 2x minus 1. And you have g of x, which is 3x plus 1 or something, 3x plus 2, let's say. And you want to see where these two lines intersect each other. So you want to see where 5x cubed minus 2x minus 1 equals to 3x plus 2, right? What values of x do these two equal each other? And you can solve this pretty simply with a graphing calculator. So for this demonstration, I'll be using an app called Graphing Calculator Pro, which has the same interface as a TI-84. So if you own a TI-84 calculator, you should be familiar with this layout. But if you don't, you can just use the same concepts and apply them to your calculator. So the first step is to go to the y equals button on the top left, right here. And just put in your two equations into the two different equations. So you have the 5x to the power 4 minus 2x minus 1 in equation 1, and 3x plus 2 is equation 2. And then once you've done that, you just hit graph in the top right corner, and you get your graph here. You get your two lines. And you want to find these 2 points here, the two where they intersect. So to do that, you press second, and then you press trace, which is right next to graph, and you go to number 5, which is intersect. And then you put one dot here on the first line, one dot on the second line, and the third dot near the intersection point. And when you press enter, it will just take you straight to the intersection point. So now you can see that they intersect at x equals negative 0.52 and y equals 0.43, right? And you just do the same again for the other intersection point. Second curve is there, and the estimate is there. And then the intersect is at x equals 1.15, y equals 5.5. And that's how you solve equations using a calculator. So we'll finish off this video with a past paper question where we're just asked to solve this question. So first things first, we'll just move all the terms to one side. So ln of x squared minus ln of 2, ln of x, and then we bring the last term to this side, right? And now we have our quadratic in disguise, so to say, where if we change this and this to another term, we'll have a nice quadratic. So let's let ln of x, let's let it equal, let's say m, right? So now we have m squared minus ln of 2 times m minus 2 ln of 2 squared equals 0. Okay, and now we have a quadratic, right? And although this number is pretty weird, it is still a constant. There's no variables, there's no m's there, so it does count as a c. So what we do next is just use our choose the quadratic formula. So m equals, b is minus ln of 2, so minus b is just ln of 2, plus or minus square root of ln of 2 squared, b squared, minus 4, a is 1, and c is minus 2 ln of 2 squared, right? And then over 2a, so 2 times 1. And now we have m equals ln of 2 plus or minus square root. So ln of 2 squared just stays as ln of 2 squared. This minus here, they cancel out with each other, so this becomes a plus. So plus 4 times 2 is 8, obviously, so 8, and ln of 2 squared, let's fix the root sign, over 2, right? And now since these are like the same, right? So ln of 2 squared, ln of 2 squared, 1 of them plus 8 of them is 9 of them, right? It's pretty simple. So we just add them together. We have ln of 2 plus or minus square root of 9 ln of 2 squared over 2. And this 9 ln of 2 squared, we can actually square root that. So this m now becomes ln of 2 plus or minus square root of 9 is 3, and square root of ln 2 squared is just ln of 2, right? And this stays over 2. And now again, it's plus or minus, so it's either m equals ln of 2 minus 3 ln of 2 over 2, or m equals ln of 2 plus 3 ln of 2 over 2, right? So let's do that on the other side now. So if we minus them for each other, we'll have m equals minus 2 ln of 2 over 2. And the minus 2's just cancel out, and you have m equals minus ln of 2. And on the other side, you have m equals 4 ln of 2 over 2, right? You just add them together. And the 4 and the 2 cancel out, you have m equals 2 ln of 2, right? But again, we weren't looking for m, we're looking for x. So how do we find x? We just bring this here, bring it back. And I have ln of x equals minus ln of 2, or ln of x equals 2 ln of 2, right? And from your logarithm laws, from your ln laws that you learned in Unit 1, we know that ln of minus ln of 2 is ln of 2 to the power of minus 1, right? And 2 ln of 2 is basically ln of 2 to the power of 2. You just take this number here and you make it an exponent here. So then you have ln of x equals ln of a half. So 2 to the power of minus 1 is a half. And the same thing on the other side, ln of x equals 4. And you'll notice that these numbers pretty simple. So you have x equals a half and x equals 4. And these are your solutions to this question.